Now we are ready for floating point real numbers. Before we continue, I would like to introduce you the new concept, what's called normalized. So if you recognize it, it's also called scientific representation. Okay, so we call it normalized because it is written in single digit integer part, followed by a decimal point and the decimal. Okay, decimal part, followed by multiply and the base. In this example is base 10 and some exponential. Okay, and the side bit is also there. It can be either plus or minus. Okay, so in this form we call it normalized. However, if you write it in this form, 0.002 times 10 to the minus 4, it's not normalized. Okay, so it must be rewritten as plus 2.00 times 10 to the minus 7. In this case, you can see the decimal point is shifted here, 1, 2, and 3. Okay, so minus 4 plus minus 3, that's minus 7. Okay, so it's going to be shifted to make this number integer part, no longer the decimal part anymore. Okay, so 2.00 times 10 to the minus 7. Now it is normalized. Alright. How about the second example? Positive 987.02 times 10 to the 9. It is also not normalized because this part is not single digit. So we have to shift the decimal point 1, 2, okay, to make it single digit to become 9.8702. Now this exponent must be adjusted. Alright, so since we shift the decimal point 2 places, so it's going to be plus 2 here. So 9 plus 2 is 11. Okay, that's what we call it floating point. Okay, because this point means the decimal point is not fixed. Earlier it was fixed, right? Now it's not fixed. Therefore, we call it a floating point, not fixed point anymore. It's a floating point. So that means the decimal point can float around to make it normalized. Okay, let's take a look at the definition. So we have to rewrite whatever number to be normalized. Okay, look at this as the magnitude again. And the magnitude consists of the integer part, followed by a decimal point, followed by a decimal part. Okay, followed by the decimal part, and multiplication sign 2 to the exponent in base 2. Okay, so the side part is up here, just like the fixed point. Minus 1 to the s represent the side part. Okay, and the decimal part, sorry, the exponent part is side magnitude as well. Okay, so let's take a look at this example. Minus 1 to the 1 times 1.0101 base 2 times 2 to the 3. So if you carefully look at this, this is normalized. Okay, because we have a single digit here, followed by a decimal point and a decimal part. Okay, multiply some base. Now we change the base to base 2. Now we would like to change it to base 10. So what should be this number in base 10? Okay. Step 1. Adjust the decimal point position such that the exponent becomes 0. Okay. In this case, the exponent is plus 3. So we need to adjust the decimal point position to make the exponent become 0. So from 3 to be 0. So what should the decimal point shifted to, left or right? It should be shifted right. Okay, 1, 2, 3. 3 times to make it minus 3. So 3 plus minus 3 will be 0. Okay, like this. So the answer for step number 1 is, if we shift to from this location 1, 2, 3, so the exponent becomes 0. All right. So step number 2, convert this number to base 10 value. As you can learn, this part becomes what? If you look at it carefully, before the decimal part, before on the left hand side of the decimal point, this part is considered an integer, right? Just like the fixed point number that we learned earlier. So it's going to be minus sign like this. This is the unsigned 1, 0, 1, 0. Sorry. Yeah, 1, 0, 1, 0. See that? 1, 0, 1, 0. So this positional value of 1 is 2 to the 3, which is 8. This bit is 0, so times 4 will become 0. This 1 is this bit times 2 to the 1, so it becomes 2. 0 times 2 to the 0, which is 1. Now it becomes 0. So it's going to be 8 plus 0 plus 2 plus 0, followed by this part. See that? The decimal part. Now I would like to call it the fragment. Okay, the fragment is 1 times 2 to the minus 1. See here, this bit is this part. So it's going to be 2 to the minus 1 is 1 over 2. That's 0.5. So finally, the minus sign is still there, so it's going to be minus 10.5 base 10. Okay, let's stop here for a moment and we will continue to the next example. All right.